Hello everybody, welcome back to How to Monkey. In today's video, we're going to be going through the first two lessons of statistics and probability for grade 11. This is Math 2, and we're going to be going through what a random variable is, discrete versus continuous, sample space, tree diagram, probability distribution table, mean, variance, and standard deviation. So at the end, you'll be able to solve your own problems with no stress. So let's begin. What is a random variable? Now, a random variable or let's make it bigger, RV, right? A random variable is just a rule that gives a number to the outcome of an experiment. So let's say, let's say I flip 2 coins, okay? Let's say I flip 2 coins. I can let X equals number of heads. Okay, so I can let that be the number of heads, right? Random variables can be discrete or continuous. What this means is discrete basically means you can count it, or it's like a whole number, so no decimals. Something like number of people, or so it can be number of people, or how many times a volcano erupts in a year, right? While let's say continuous, right here, continuous is measuring. Now, what's the difference, right? What's the difference? Measuring is something like height, right? We get height, weight, something like that, where there's gonna be decimals. It's gonna be decimals, and it's gonna be focusing on like things that are so basically discrete, countable, okay? Continuous, measurable. All right, but today we'll only be dealing with discrete, okay? So for our simple problem today, let's say I flip 2 coins. So 2 coins. All right, let's say I flip 2 coins, and let's let X be equal number of heads. All right, number of heads. All right, so we need to find the sample space. Now, what is the sample space? Okay, so what is the sample space? But before that, we need to find, again, the sample space, the probabilities, make the probability distribution table, find the mean, the variance, and the standard deviation. So let's go through it one step at a time. So when flipping 2 coins, we already know the possible outcomes, right? But if you don't, then you can use what's called a tree diagram. So we know that 1 coin, right, gives you heads and tails, right? This is your first coin. That's that 1C, first coin. Now for your second coin, you can also have heads or tails, right? So let's make this heads or tails, right? But it becomes like this. Now, why does it become like this? This basically states that if, for example, on your first coin you flip it, boom, it lands on heads. You get your second coin, and we know that the only two probabilities or possible outcomes of flipping a coin is heads or tails, so therefore heads or tails. This basically states that if this is your first outcome, then these are your two possible outcomes that can come after that. Likewise with this, if you flip your first coin and say, hey, it lands on tails, you get your second coin, and it only has two possibilities or two outcomes, which is heads or tails. This states that this is the outcomes of coin 2. These are the outcomes of coin 1. So what does that mean? Okay. We know that the possible outcomes are... Okay, so we're back. We know that the possible outcomes from that is heads, right? And then we can also have another head. And then we can also have heads and tails. And likewise, we can have tails and heads and tails, right? As shown right here. You can have heads, tails, heads, tails. Now, what this is already the sample space. Basically, it's a set of all your possible outcomes. So this is just denoted by S is equal to this. And then you can have this little cute bracket. I'm not really good at it, so heads, tails, heads, and tails. All right. Now, the tree diagram is optional, but it helps you visualize how we get those four outcomes, how we got these, right? Because we obviously got them from this being your first outcome and this being your second. This being your first outcome and this being your second, right? Now, our x, let's go back to our x. Our x is number of heads. I'm sorry for the bad lighting, but yeah, number of heads, right? So let's assign x to each outcome. So how many heads does x is looking for heads, right? So now what we're gonna do is count how many heads there are. Okay, how many heads does this have? You're right, it has 2. How many heads does this have? 1. And these has 1. Now what about this? It has 0. Correct. So now what we're gonna do is we're gonna denote that here, x right here, x is the possible values of x are x is equal to cube bracket right here, 0, 1, and 2. Oops, bad bracket. I don't really care. So we know that the values of x can be 0, 1, and 2. Why? Because here it can be 0. That means there are no heads if the outcome of flipping the 2 coins are tails and tails. That means your first coin, you flipped it, boom, tails. Your second coin, you flipped it, boom, tails again. That means there are 0 heads. But what about the 1? Well, the 1 means that you either got heads on your first coin and then got tails, or tails on your first coin and then got heads. Now, I think you know why there's a 2. That's if the outcome was you got a heads and then you got another head. So let's move on. Because each of the outcome is equally likely, each has a probability of 1/4. Now, why is it 1/4, right? Because they're all likely. And we know that P of x is equal to, right here, favorable outcomes and then over all possibilities and outcomes. So what we're basically just gonna do is just take this one right here and then put a 4 over it. And that's basically it. That's basically it. Well, no, not really. So what we're gonna do is, what if x is equal to 0 heads, right? This means that P of 0, let's move this up right here so you can see. Don't worry, we'll use that paper later. So P of 0 is equal to 1/4. Now why is it 1? Because there's one chance that you get 0, right? And then there's 4 probabilities in total, or 4 possible outcomes. So you basically just put, okay, there's one possibility that I get a 0, and then there's 4 possible outcomes. So it's just 1/4. Pretty simple, right? Now, what if x is equal to 1 head? 1 heads. P of 1. Well, here you can actually see that there's 2 possibilities in which you can get 1 head. So what does that mean? There's 2 possibilities. So you put 2 and then all possibilities, which is 4. So what we're basically looking for here is just your favorable outcomes over all possible outcomes. So in this case, we're looking for our favorable outcome is if we get 1 head, and we get 1 head from 2 outcomes. Hence why it's 2/4, because 4 is all of our outcomes, possible outcomes. Now this is just the same with, I mean 0 heads is just the same with 2 heads, in which case there is P of 2 1/4, because there's only 1 possibility in all 4 possibilities that we get 2 heads. Now, what does this equal? This equals to 1, right? Because 1 plus 2, 3 plus 1 is 4. 4 divided by 4 is equal to 1. Now, you must always check if all probabilities add to 1, because it's a rule in which case 1 is 100% and 0 is, well, 0. So the closer you are to 1, the more possibility it has of happening, with 1 meaning it's inevitable and 0 meaning it's impossible, and everything in between, right? So you can't go over 1 in this case. So let's go through the probability distribution table. So once we're done with all that, we basically just put it into a table. What does this mean? How do you construct it? It's basically just x and then P of x. Oops, right here. X and P of x right here. Yes, x and P of x. Here we have 0, 1, and 2. You basically just put all the possible values of x and then their corresponding values of P of x. This is your P of x, by the way. So what is p of 0? Just put that there. P of 0 is 1/4, right? 1/4. But let's turn that into decimal. It's pretty easy. 1/4 is 0.25. And then this is 2/4, which is just 0.5. And then 2, which is the same, 1/4, is equal to 0.25. Now, as you can see, if you add all of that, it adds to 1, right? Now, remember how to make this table because it's very important. It's one of the key lessons, actually. Now, next, we're gonna find the mean. Now, how do we find the mean? Well, as you can see right here, the formula for the mean. Oh, buddy. Oh, that is not good. Okay, so the formula for the mean is right here. Wait a second. Okay, so the formula for the mean is this sign, which is, I believe, mu or something. Correct me if I'm wrong. And then this is what we learned in grade 10, the sigma thing. So the summation is basically adding everything up. So n, and then the sign, and then I is equal to 1. This is just their formula. Make sure to remember their formulas, okay? And then it's x, and then multiplied by p of x, basically. So how do we construct this? All right. Let's plug in the values, all right? So we know that the mean, or the sign right here, sorry about the handwriting, is the summation, right, of I is equal to 1. And then xi multiplied by p of xi. All right. The lighting is not giving. But anyways, let's plug the values, all right? We know that the values are right here is equal to 0 times 2.25 plus 1 times 0.5 plus 2 times 0.25. Now, why is it like this? Basically, what we're doing is just multiplying x with its corresponding value of p of x. So as we got back from the table, which I'll show again, as you can see from the table right here, lighting, amazing lighting right here, x is 0 is 0.25, 1 is 0.5, and then 2 is 0.25. So that's basically how we got our values right here. So moving forwards, let's continue. So we just multiply. 0 multiplied by anything is, well, 0. And then anything multiplied by 1 is just the same. And then 2 times 0.25 is just 0.5. So we add everything up and we get 1. What does this mean? Well, that means that the mean, or this symbol, is equal to 1. And that's how you find the mean. Now let's move on to variance, okay? What is variance? Variance tells us how spread the values are from the mean. Now, it may sound a little complicated, but it's really not all that. So, there's this symbol. Our teacher called it like a whistle from a police officer. It's pretty sick, right? It's basically the same, but the difference, which I'll show you right here, is equal to 1, is here. This is the difference right here. X of 1 minus mean squared multiplied by p of x, like that. Now it may sound a little difficult But I swear, it is not all that. We already know that our mean right here is equal to 1, right? So what we're really gonna do is just do the same thing, but like we minus x with the mean, square it, and then multiply. So again, the formula for the mean is this. Okay, my phone. The formula for the mean is this. And then the formula for variance is this. And basically what gets added is just minus mean squared. So make sure to remember that. So let's compute for each term, okay? You don't have to do it like this, but I like doing it like this because it's clearer and simpler for me. So we have x and then the values of x, which is 0, 1, and 2, right? And then we have x minus 1 right here. X minus 1 is negative 1, 0, and 1. What does this mean? So 0, we minus it by 1, hence x minus 1. And then here, it's just 1 minus 1, which is 0, and then 2 minus 1, which is 1. Alright, moving forwards. Which is x minus 1 squared, which is just, after we get this, we just square it. So negative 1 squared is 1, 0 squared is 0, and then 1 squared is 1. And then after that, we multiply by p of x. So it's just 1 times 0.25, which is 0.25, and then 0 times 0.5, which is 0, and then 1 times 0.25, which is 0.25. Now, adding this together, this means that our variance is right here, squared is equal to 0.5. We're just adding 0.25 and 0.25, which gives us 0.5. Now, how do we get standard deviation? It's so easy. I swear, it's so easy. Basically, you get this. This is your variance, right? After that, you just square root it. So what does this mean? Okay. This means that you get your, here, squared is equal to 0.5, right? We just square root. So now we get, oh my gosh, amazing drawing. This is equal to, I'm pretty sure it's like, you can get your calculator, guys. Tell me if I'm wrong, but I'm pretty sure it is 0.707. And that is your standard deviation. It's very easy. Standard deviation is just square root. So it's just square root your variance. So nothing really changes. You just add a square root. So basically, the difference between all three formulas is for the mean, it's this, summation xi times p of xi. And then here we're just adding minus mean and then squared. And then for deviation, it is just square root. So let's summarize everything, okay? We know that the sample space, which I showed, is heads heads, heads tails, tails heads, and tails tails. This we got this from the tree diagram. And then we know that random variable x is equal to the number of heads. We know that p of 0 heads is equal to 0.25, We know that P of one head is equal to 0.5, and we know that P of two heads is equal to 0.25. Refer to the answers that we got during the video. And that the probability distribution table, it's pretty easy to make, but let's write it anyways. It's x, P of x, and then the values of x, which is 0, 1, and 2, and then the corresponding values of P of x, which is 0.25, 0.5, and 0.25. This is a scuffed drawing, or a scuffed table actually. You should definitely make it better for the exam, but this is just how I'm gonna make it, because yeah, I don't really want to do all that. So we know that our mean, let's just pour symbol again, is equal to 1. Our variance is equal to, we should do the symbol, squared is equal to 0.5 or 0.5, and then our standard deviation, or just the sign, is equal to 0.707. And that's it. Really, I swear, that's it. We've covered random variables, sample space, tree diagram, probability distribution table, mean, variance, and standard deviation, all in one simple example. If this helped you, make sure to like, comment, and subscribe, and definitely good luck on the math exam. Thank you, and bye-bye.